we're looking at the sample public exam. We're going to look specifically at Chapter 1 questions, the questions from Chapter 1 on the exam. So when we look at multiple choice, number 1, it says, given the Venn diagram below, what is the number of elements in both A and B? In both A and B, if you recall, that's the intersection. That's the intersection. And this is from section 1.3. So what's in both A and B? We have 2 elements. It says the number of elements. 2 elements are in both A and B. Now, so there are a couple different things that they could ask you based on Venn diagrams. For example, if they asked you the number of elements in A, there would be 5 elements in A. 1, 2, 3, 4, 5. If they asked you the number of elements in B, that is also 5 elements. If they asked you the number of elements in A minus B, if you recall that, that was the number of elements in A, but that are not included in B. And of course that would be 1, 2, 3. And once again, they could ask you the number of elements in A union B. If they ask you the number of elements in A union B, that's 1, 2, 3, 4, 5, 6, 7, 8. So these are the types of questions they could ask you based on a Venn diagram. Let's look at another Venn diagram, multiple choice number 2. Given the Venn diagram below, which elements are in sets A, B, or C? That is the union of A, B, and C. So that means anything in A or B or C. And so when we look here, we have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. All the elements are inside, and of course our answer would be D. Multiple choice number 3, there are 26 students in a classroom, so that's the universal set. 11 students have blonde hair, so the number of that have blonde hair is 11. 16 have brown eyes, that means the number of elements that have brown eyes equals 16. 6 do not have blonde hair or brown eyes. 13 have blonde hair or blue eyes, but not both. How many students have both blonde hair and blue eyes? So we're looking for the intersect. Here we can construct a Venn diagram. And we have blonde hair and brown eyes. And according to this, 6 are on the outside. They do not have, 6 do not have blonde hair or blue eyes. That means the number of students in the union will equal 20. We have 11 students in H and 16 students in E, in set E. That gives us a total of 27, but yet there should only be 20, so 27 subtract 20 will give us 7 here in the middle. That will give 4 with only blonde hair and 9 with only brown eyes. So we could also look at this from section 1.3, the principle of inclusion-exclusion says that the number of elements in the union of 2 sets is equal to the number of elements in H plus the number of elements in E, subtract the number of elements in the intersect. Now we know there's 20 in the union, and in H there's 11 plus 16 in E, so this must be 7. If we solve the equation, the intersect must be 7. A is a set of positive even integers less than 12. B is a set of multiples of 3 between 4 and 20. Which elements is or are not in the intersection? It's not in the intersection of of A and B. So we're talking about the complement. This is the complement of A intersect B. So in set A, there's a set of positive even integers less than 12. So that would be 2, 4, 6, 8, 10. In B, it's the multiples of 3 between 4 and 20. So that would be 6, 9, 12, 15, 18. Now it says which elements are not in the intersection. So we have in the intersection, in the intersect, there is 1. That's in the intersect. So that are not in the intersect is everything else. 2, 4, 8, 9, 10, 12, 15, 18. And that will give us B. Now we're looking at a constructed response item. It says 200 students wrote exams in math, biology, and English. The Venn diagram below represents the percentage of students who wrote these exams. Algebraically, determine the percentage of those students who wrote all 3 exams. So that's the intersect of all 3. And determine the number of students that this represents. So we have, here we use the principle of inclusion and exclusion, which is given to us on our formula sheet. And it'll be that the number of students in B union M union E is equal to the number of students in B plus the number of students in M plus the number of students in E. Subtract the number of students in B intersect M. Subtract the number of students in M intersect E. Subtract the number of students in B intersect E plus the number of students in all 3. B intersect E intersect M. And so in the union there's 200 students. But the Venn diagram is represented by percentage. So since there's no percentage of students outside of these courses, we have 100% are in the union. The percentage of students in biology is all inside of B, which would be 2x plus 6x, which is 8x, and 1 plus 1 subtract 7. So we have 8x subtract 5 in B. In M, in math, we have the 6 plus 4x is 10x, and 5 plus 27 is 32. So we have, in math, we have 10x plus 32. In English, we have the 6x plus the 4x, which is 10x, and 3 plus 27. So that would be 10x plus 30. Then we're going to subtract, and this is where the tricky part comes in. We're going to subtract what's in the intersect of each. In the intersect of B and M is going to be 6x plus 1. In the intersect of B and E will be 6x plus 1. And in the intersect of M and E is going to be 10x subtract 27. So I'll just put it in here. 10x plus 27. And then finally we'll add the intersection of all 3, plus 6x. So we have 100 will equal, when we remove the brackets here, we must recall we're subtracting all of this. So this will be subtract 6x, subtract 1. We're subtracting all of inside the bracket. So we have 8x subtract 5 plus 10x plus 32 plus 10x plus 30. Here it is, subtract 6x, subtract 1. Subtract 6x, subtract 1 again here, distributive property. Subtract 10x, subtract 27, plus 6x. So be very careful here. You're subtracting everything inside the bracket, and therefore it's the negative 1 is distributed throughout all of it. When we collect the like terms, we will have 100 will equal 12x plus 28. This will give us 100 subtract 28 will equal 12x. 72 will equal 12x. So 6 will equal x. So we have 6 equals x. That means 36% of the students are here in the intersect, are doing all 3 exams. And then we take the 200 students in total and times it by 0.36 to determine how many students that will be. That will give us 72 students. 72 students out of the 200 will write all 3 exams. So you have to be aware that your constructed response item from Chapter 1, which will be number 51 on the exam, will come from, most likely, be on the principle of inclusion-exclusion. You also have to be aware that if there's any values outside here in the Venn diagram, they are not included in the union of those numbers. So for example, if we had 5% outside here that didn't do any of these exams, then this would be 95%. So be very careful. Once again, be very careful when you're subtracting expressions, binomials, from when you're subtracting binomials here, or the intersect of 2 sets. So it is very important that you understand how to use this principle of inclusion and exclusion for the constructed response item. In summary, multiple choice number 1 to 4 on the public exam will be from Chapter 1 set theory, and number 51 on the exam will be from Chapter 1. And it is common that this question will involve completing Venn diagrams and or using the principle of inclusion and exclusion to answer questions. Once again, the principle of inclusion-exclusion will be given to you on your information sheet, your formula sheet.